Hey there everybody, welcome back to another Chem Complete lesson in the General Chemistry series. And today we're going to dive into probably the first area where students really start to have issues, and that is unit conversion and dimensional analysis. The terms, you can kind of use them interchangeably. So what have we talked about so far? And I suggest you check out the other videos for the Introduction to General Chemistry portion. We have talked about physical and chemical changes, or physical and chemical properties. We have talked about an introduction to general chemistry, matter, atoms, elements, mixtures, homogeneous and heterogeneous mixtures. Most students are okay up to this point, and it's at this point that they start to have some issues regarding the material that they come across in general chemistry. And unit conversion and dimensional analysis does not need to be difficult for you. It really doesn't. But you have to know how to approach it. And I try my best to outline this in an easy fashion so that it makes sense. Now, I just want to mention, there is an older video on this. You're welcome to go check it out. This is basically an upgraded video. When I started this channel originally started just as a little pet project for one of my general chemistry classes back when I started teaching. It's grown into a little bit of a larger project now, so I have higher quality recording equipment, a higher quality laptop. So this is basically a rehashing of that particular portion, and you're going to see that with a lot of videos. If you go back and you look at like the videos from 2014, early 2015, their quality is going to be very low in terms of the audio. So I just wanted to mention that. I'll probably put an annotation or something like that in the old video that leads to the newer one, which you're watching right now. So let's go ahead and get started on this. We got a lot to cover when it comes to this. Oh, one more point I want to bring up. We are going to have a separate lesson shortly on significant figures and scientific notation. So it's important that you first get comfortable with unit conversion and dimensional analysis. That's usually always my first goal for students. I want them to get comfortable with the prefixes. So what's a nanogram versus a milligram versus a kilogram? You need to know that kind of stuff. Only once you know how to actually convert units back and forth will we start talking about how many digits you should be reporting, and that's significant figures. That is not to undermine significant figures whatsoever. So those of you that are watching this, if you're aware of significant figures, you should always be using them. But because of the order in which I'm presenting this material, we're not using significant figures in this particular video. I will try to mine them somewhat often, but we're not going to take a lot of time to explain significant figures. That'll be in a separate video. So just keep that in mind, whether you're an instructor, a student, whatever that's watching. If you've come across significant figures, absolutely, you need to be minding them the whole time. But this particular unit is for unit conversion and dimensional analysis. Okay, so with that brief caveat, let's get started. All right, so when we're dealing with this, talking about unit conversion and dimensional analysis, you need to first get familiar or familiarize yourself with your base units. Okay, and so when we talk about base units, we're talking about the main unit that tends to be utilized or accepted. It's also known as the SI unit, the Standard International Unit, or System International Unit. And that stems from using the metric system. So everybody, when we deal with chemistry, we use the same measurement techniques. Now, if you're watching this and you're located in the United States, like I am, you are used to using the imperial system, where we're doing gallons instead of liters. We're doing miles or inches or yards instead of, meters and kilometers and things like that. We do pounds very often instead of grams. We do ounces instead of liters, or I think I may have said gallons. But things of that nature, you're going to have to be able to convert back and forth when you're doing that stuff, and we'll talk about that. Okay, but the base units that we're going to be using in general chemistry are utilized through the metric system. Now, technically, I'm gonna put this up here. Mass, which is one of the big ones. Okay. Technically speaking, the SI unit for mass is kilogram. That's what we use to measure with. But I am actually going to put gram here because kilo is one of the prefixes, and I really would like to separate the prefixes from the base units that we're using. So we're going to talk about mass being in grams to start with, okay? But just note, in most books that you come across, it's going to say kilogram as the main SI unit that you'll come across for that. Okay, so I have a list of them here. Let me check my notes here. So mass, all right, we've got mass. We have length. It's another common one. So length is going to be in meters. We have time. Time is actually one that's somewhat universal depending on whatever country you live in, excuse me. Time is measured in seconds, right? So that's the standard unit. We can do minutes, hours, you could lead up to days and things like that. But seconds is what we tend to measure something in. So when we get in general chemistry, when we get to a point where we're doing like the kinetics of reactions, measuring how fast reactions go, it's going to be per second when we're dealing with those sort of units. We're not going to be dealing with any other type of bizarre time unit, and that is one that we tend to utilize, again, universally. Everybody uses seconds. Temperature, a lot of students will actually get confused for temperature until they're more into their general chemistry course. A lot of people think it's Celsius. It's good that you don't say Fahrenheit, because it is certainly not Fahrenheit, and we do use Celsius quite a bit. I would even argue it's sort of a secondary base unit for temperature. But the proper unit is Kelvin with a capital K. Kelvin is the temperature we use as the universal temperature unit. The reason that we use Kelvin is that it does have what we call an absolute zero. So when you say a scale has an absolute zero, it means there is a 0 point at which you cannot get any lower than that point. Okay, so that makes sense. When we get to grams, if I have 0 grams, I can't have -1 grams of something, right? I can't have -2 kilometers. Now, if you're talking about physics and directionality, okay, with vectors, you may have negatives that show that, but it doesn't mean that the actual concrete value of that unit is negative. You can't have negative meters or negative seconds. You can, however, have negative Celsius, and you can have negative Fahrenheit. When they say it's going to be -10 degrees out today, whether they're talking about Fahrenheit or Celsius, they are talking about a negative temperature relative to 0 Fahrenheit or Celsius. If you say it's going to be 0 Kelvin out, which, by the way, you cannot reach absolute zero, you can come very, very close, but that gets into entropy and the laws of thermodynamics. That's for a separate lecture. But if you say that you're at 0 Kelvin, you can't go below that. There's no such thing as -1 Kelvin. So Kelvin has that absolute scale, and that's why that's used there. Okay. So one of the other ones that we have is amount of substance. And this one tends to get sometimes confused with the first base unit we have up there for mass. Amount of substance is actually measured in moles, and we're going to talk about moles a lot in upcoming units for general chemistry. When we deal with mass, and remember, mass is basically matter that takes up some amount of space, that when we're talking about matter. Mass, we're dealing with grams/kilograms. When we talk about the amount of substance in something, especially on an atomic or molecular level, we're dealing with moles. So in other words, if I have 3 grams of gold and 3 grams of silver, both of them have a mass of 3 grams, but there's going to be a different number of gold atoms in the 3 grams of gold versus a different number of silver atoms in the 3 grams of silver. And that's because those 2 atoms, a silver atom and a gold atom, have a different mass inherently. So whichever one is heavier, there's going to be fewer atoms making up those 3 grams. And so then we talk about moles. How many moles of gold do I have? How many moles of silver do I have? We're talking about it on an individual piece-by-piece level. Okay. And then finally, another big one is volume. These are certainly not all of the base units. You can talk about when you start getting into electrical units and things like that, but by and large, these are the ones we're going to use in chemistry most often. And the unit there is going to be liters. So, with the base units out of the way, the next thing we want to talk about are the prefix units. So the prefix units, I have a big list here and we'll go through. Not all of these occur very often. The first one that I'm going to mention, and there's larger ranges than this, I'm giving you probably the range that you most likely would come across. Even in this list, there are certain ones that I would argue aren't going to come up quite as often, but this is the most common list here. So tera. 10 to the 12th is the prefix. So that means if I have a teragram, I'm talking about 10 to the 12th grams. It's a very, very large unit. We're talking about large units. Where tera comes up most often in everyday language right now, computers are finally up to terabytes when we're talking about hard drives. So you may see some of the more modern hard drives, certainly not back from the early 2000s, but the late past 5 years or so, you start buying laptops or especially external hard drives that have a terabyte worth of information, right? So tera means 10 to the 12th. So you'd have 10 to the 12th bytes. That's a lot. That's a 1 with 12 zeros coming after it. And then you have giga. And again, when we talk about computer memory, that's a very common one. That's 10 to the 9th. Mega. Mega would be 10 to the 6th. And then after mega, we start getting into the realm of things we would use fairly readily on an everyday chemistry basis, and that is kilo or kilo. Okay? And so you may have heard of this, certainly in computer terms, kilobytes, but you've also probably heard of kilometers, right? You've heard of kilograms. You've heard maybe about kiloliters. That's not quite as common. We usually have milliliters or something like that, but you could have it. Kilo is a very common prefix. It's used very often because many of the objects that we use every day we talk about on a kilogram basis, which is also why when I mentioned over here that the base unit for this many times is considered kilogram. You think about human beings. I know, again, in the US we talk about pounds, but everywhere else you talk about kilograms when you're measuring yourself. How many kilograms do you weigh, right? If you go to the store, you pick up something in kilograms when you're measuring it. Grams would be slightly too low of a scale, okay? Maybe you do use grams often in a chemistry lab, but outside of that, not quite so much. Then we have base unit, which I'm just going to put a little null sign next to, okay? Because base unit is what we have over here. So we're adding the prefixes to the base unit, right? Base unit is meter, and then it's kilometer or kilometer when you add the kilo prefix to it. So the prefix units are latched onto, they're different from the base unit. They basically are you could almost view them as an adjective. They're helping to describe or to give some clarity to the base unit, okay? So then we have deci. Deci tends not to be used quite as often. Sometimes you may see it in things like the medical field. Deci is going to be 10 to the minus 1. All right, and then we have, what do we have after that? Centi. Here comes some of the most common ones. We certainly know centimeter. Most people know centimeter. That's 10 to the minus 2. Probably the best known of the bunch, milli, right? Millimeter, milligram, all that kind of stuff when you're talking about active drugs or things like that. That's 10 to the minus 3. Then we have micro, and I am going to put a little symbol next to this, the mu symbol. And that is, it looks kind of like a U, except you have this extra tail over here. Micro is 10 to the minus 6, and I put that there because it's represented by this symbol right here. So a lot of these other ones, they have just the letter in front, D, right? Centimeter would be C, millimeter would be small m, kilo would be K, mega would be big M because milli is small m, so on and so forth if you were working with that. There's two other major ones that I tend to list. Nano, okay, that would be a small n, is 10 to the minus 9th. And then we also have pico. And sorry for those of you that may hear my dog barking. I don't know if you can. I think the lawn mowing people are here. 10 to the minus 12th. Okay, so pico, if I talk about a picometer, a picogram, I'm talking about a very, very tiny amount. Very tiny. Okay. Yes, there are units after this. There's femto for 10 to the minus 15th and so on and so forth. However, these are the major ones you're going to come across. Most people don't utilize femtograms. Okay, the smallest usually would be nanograms if you're dealing with a very, very small scale operation in the lab. So those are your prefixes. Now, I should mention, I'm probably going to make this a two-part video. So we'll have part 1, which is going to be the explanation. Part 2 will be the practice, because otherwise this could run on to be like a 40-minute video. So the next thing I want to do is to actually look at unit conversion itself. So take a second to copy this down if you need to. You should be able to find this in any decent general chemistry book. And then we're going to do a little bit more clarification on some of this. Okay. All right. So I'm going to clear this off. So when we're doing unit conversion, what I always suggest to my students is you want to set up what's known as a canceling table. Okay. So, oops. Forgot my C there. Canceling table. This is the easiest way to do this, in my opinion. I still use them as an instructor. Now, many instructors, and these technically are canceling tables, are going to take fractions. They're going to take one and multiply it by another fraction, multiply it by another fraction, and keep going on like that. All I'm suggesting is that you set this up in a simple table fashion, like this, right? And this is where your known will always go, up in this corner. So what do I mean by known? I mean that you're going to have a problem that tells you have something. So let's say it says you have 2.5 and then some unit x, where x could be grams, meters, whatever, right? So up here, I'm going to put 2.5, whatever my unit x is. That's where I take whatever is known in the problem, I grab that, I put it up in that left-hand corner. Okay. Now, the goal here usually is that I want to convert x into something else. Now, I may want to keep the base unit, so I may want to convert milligrams into grams or something like that. Or I may want to change the base unit. I may want to turn centimeters into inches, something completely different, and toss the meters out, right? So whatever that happens to be, we'll go ahead and we'll call that y. Now, this is important. Whatever I put down here in this quadrant right here, okay, I probably shouldn't put x, even though I am going to want that down there in a second. We are going to divide this top portion by whatever is down here. Whatever I'm going to put up here, I'm going to multiply that portion by. So in other words, 2.5x is going to be multiplied by whatever I find here and divided by whatever I find here. Now here's the key with unit conversion and dimensional analysis. I want to turn some unit x into some unit y, right? So where would I want that? Well, if I want x to go away, I want to divide by x, because x divided by x will cancel out. And then I want some new unit y, right? And I can do this more than once. Maybe there's multiple steps I need. And at some point, when we start doing things like limiting reactants and stuff like that, you will need multiple steps. You're going to need to be able to go from x to y to z to a to b to so on and so forth. So I could also take it one step further and say, maybe I want to get rid of y and turn this into z, so that whatever all of this comes through as, I end up with some unit z, because y has canceled out with y, and x has canceled out with x, and of course there would be numbers here, right? So however many x's are in a y, however many y's are in a z, and then you work through that, you find out how much z you have. Okay, so that's the basic premise, and you're going to need to understand how to set these up. So what I was saying before is that many instructors will turn around and they'll say, I've got 2.5x, and I'm going to multiply that by some number y over some number x, and then I'm going to multiply that by some number z over some number y, and so on and so forth. So their setup looks like this. And I think for many students it's easier in a canceling table. It keeps it rigid and formatted so that they can see exactly what they need at each portion and where they're canceling out. Whereas I think if you're not as used to it, these fractions can start to complicate things. But you should be comfortable with this, especially if you're in a general chemistry course at college level. You should have had enough algebra in your high school level to be comfortable dealing with this. Okay? But that's how we'll approach it to try to make it easy for everybody. Alright, let's see what else I need to talk about here. And again, I'm sorry if you hear any noise. I do think the lawn mowing people are here. Alright, so the next thing we're going to talk about is, okay, this is going to wrap up this video, and then we'll practice in the next one. I've got intra-unit conversion versus inter-unit conversion. And I was kind of hinting at this a moment ago, right? So intra unit conversion. And what is the difference between that versus inter? Very similar terms. And it's probably good that you learn this now, because intra versus inter are going to come up multiple times in any type of science class, especially chemistry. Okay? Intra means within the same, within self. Okay? So intra unit conversion is going to be specifically talking about when I want changes only to the prefix, not the base unit. All right, so what does that mean? That means whatever my base unit is, I don't want to change the base unit. I want to just change the amount of that base unit that I'm working with. So, for instance, if I have grams and I'd like to convert them to milligrams, point here being grams and grams, right? Gram base unit, milligram, some prefix with the base unit. I'm not changing this into pounds or something else, right? So, for instance, if I'd like to go from kilometers to millimeters, meter, base unit is not changing, only the prefix is changing associated with that base unit. Inter-unit conversion, okay, meaning between units. So now, it's not so much the prefix I'm worried about, I'm looking for a change between base units. And that is something along the lines of, if I have kilograms and I would like to convert that into pounds, right? If I have gallons and I would like to convert the gallons into liters. Now I'm talking about a completely different base unit. A gallon and a liter are separate base units from one another. I can convert from one into another. Now sometimes they have to be convertible. So in other words, gallon is dealing with liquid measurement and liters is dealing with liquid measurement. It is usually not as simple. I cannot always convert one unit to another. So I cannot convert seconds into liters. Units of time and units of volume are not interchangeable in that methodology. Okay? Sometimes you can interconvert units back and forth. So milliliters, liquid volume, can be converted into meters or centimeters, because you can talk about cubic centimeters, which is volume, right? A centimeter by itself is length. A centimeter squared or a meter squared is area. Think about if you get an apartment or something like that, right? They talk about square footage or square meters. And then if I take that up to the third, so I take volume to the third, if I take length to the third, so centimeters cubed, now I'm dealing with volume, a cube, right? That has some volume to it. So I can convert some volume with length units, but the length units have to be raised to the proper power in order to do that. So that's going to cut it off here. I think that's good for this portion. The next portion, we are just going to practice unit conversion. So that'll be a part 2 to this. And I will certainly let the lawn mowing people finish their job first. So I will see you guys there, okay? Thanks a lot. Please remember to like, comment, and subscribe if this was helpful.